But this is also a character study of an idea, from its contemporary cultural presence to its philosophical foundations. Snow Crash neatly illustrates the tensions at play when algorithms stitch together computational, mythic, and cultural spaces. It's not so much a story about the power of code, but its awkward embrace of the real, the ideal, and the imaginary in the guise of the algorithm. This figure of the algorithm as a quasi-mystical structure of implemented knowledge is both pervasive and poorly understood. We have never been closer to making the metaphor of fully implemented computational knowledge real than we are today, when an explosion of platforms and systems is reinventing cultural practice and identity, often by implementing a may, downloaded as an app or set up as an online service. We are surrounded by nom-shubs that we obey almost unquestioningly, from the dialog boxes and prompts we fill out on social media platforms to the arcane computation of credit scores. To begin excavating the algorithm, we need to understand the full scope of computational thinking and its interactions with the mythos of procedural language, starting with what we think algorithms ought to be. The Cathedral of Computation. When technologists, researchers, and entrepreneurs speak about computational culture today, this deep myth of the algorithm is typically obscured by layers of rationalizing rhetoric and the procedural metaphors of software design. Indeed, the most prevalent set of metaphors seems to be that of code as structure. Platforms, architectures, objects, portals, gateways. This serves to both depersonify software, diluting the notion of software agency. Buildings are passive. It's the architects, engineers, and users who act. And reifying code as an objective construct, like a building that exists in the world. Yet even within this architectural language, the mythological figure of the algorithm reasserts itself. Consider the popularity of the cathedral as a metaphor for code. George Dyson's wonderful history of the rise of computation is titled Turing's Cathedral. Another classic instantiation is Eric Raymond's book on open-source software development, The Cathedral and the Bazaar. Raymond was arguing for the more transparent bazaar model rather than the top-down approach of the cathedral. But perhaps the best analogy was offered at the IEEE Computer Society in 1988. Software and cathedrals are much the same. First we build them, then we pray. This was meant as a joke, of course, but it hides a deeper truth about our relationship to the figure of the algorithm today. The architecture of code relies on a structure of belief as well as a logical organization of bits. The cathedral is not a perfect metaphor for computation, but its flaws signal precisely what we are missing. A cathedral is a physical and a spiritual structure, a house of God. In that sense, the physical appearance of the building tells particular stories about faith and practice, for example, a baptismal font, a nave pointing east, illustrations of biblical stories. But it also suggests a particular mode of access to the invisible space of religion, the house of God that exists beyond physical reality. Transubstantiation, relics, and ceremonies are all part of the spectacle of the cathedral that reflect the invisible machinery of faith. Yet most of that machinery inevitably remains hidden. Schisms, budgets, scandals, doctrinal inconsistencies, and other elements of what a software engineer might call the back end of the cathedral are not part of the physical or spiritual facade presented to the world. Indeed, when the spectacle stutters for a moment and some uncomfortable fact lurches into view, the normal instinct is to ignore it, to shore up the facade of the cathedral in order to maintain one's faith. A cathedral is a space for collective belief, a structure that embodies